Hi, and welcome. I'm excited today to show you some of the progress of NIH's Bridge to AI for Clinical Care Data Generation Program and introduce you to our principal investigators, our broader team, and the entire community that's coming together to undertake the grand challenge of improving recovery from acute illness by creating a national infrastructure for clinical care AI. My name is Eric Rosenthal, and I work as a critical care physician and a neurologist at Massachusetts General Hospital, and I serve as the contact principal investigator for this program, which is a national collaboration within the Chorus for Equitable AI network. We're undertaking this grand challenge by collecting data that's normally acquired in real-world practice in the hospital. This environment can be a very busy and fast-paced environment where providers taking care of patients don't always have access and integration of all the data that's being acquired. And even when they do, they may not have the ability to have insight that would be available through machine learning and artificial intelligence.
Hi, my name is Ishan Williams, and I'm a faculty member at the University of Virginia School of Nursing. I'm a trained social and behavioral scientist, and I co-lead the Ethics and Trustworthiness in AI module team with my colleague, Dr. Ashley Cordes. We have assembled a multidisciplinary ETAI module team to assist in developing an ethical research plan to foster, reinforce, and safeguard ethical and trustworthy AI across all our modules. Our overall goals in the ETAI module is to convene and share ethics guidance for data generation, analyze ethical and legal frameworks, and perform original ethics research to develop and deploy tools, best practices, and resources to address challenges impacting data generation, access, privacy, and algorithmic equity. Currently, we are seeking to better understand the diversity of patient and clinician attitudes toward collection of ICU data for AI-related research and development, including patient and family reported satisfaction with informed consent and assent processes. We have successfully held 2 focus groups with the expectation to conduct 6 more sessions over the next few months, with a specific focus on underserved and minoritized populations.
Hi, my name is Ashley Cordes, and I'm a co-lead for the Ethics and Trustworthiness in AI module team and a faculty member at the University of Oregon in Indigenous Media Studies. As Ishan shared, we're in the midst of holding focus groups, and one granular subset of those focus groups will be focusing on collaboration with Indigenous peoples who are often underrepresented in medical AI research. Now, last year, we collected and textually analyzed Indigenous AI guidelines, data sovereignty protocols, health policies, and 575 nations' tribal vision and value statements. So we did that using participatory action research to build out the best possible questionnaire. Now what we're doing is recruiting the most diverse Indigenous focus groups that have ever been conducted in the field in order to avoid having participation from just the most populous tribal nations, and also to destabilize the homogenized idea of Native Americans and their data practices that exist in medicine. We will inform ETAI best practices, both inside and outside of Bridge to AI, by illuminating empirically grounded perspectives, informing ethical operating procedures, thinking about data curation, algorithmic development, and privacy processes informed by diverse stakeholder attitudes. This will also be achieved through a Delphi method in order to build consensus and inform optimal ETAI approaches, and that last part will be led by researcher Dr. Michael Young.
Through our AI bootcamp last year, we offered 1 full day of introductory AI courses so that the learners can become more familiar with some of the technical as well as also hands-on skills that they would need when working on real-world clinical problems. In just one event, we had 50 trainees that participated in the program, and they learned about some of those aspects, greatly helping to improve their AI proficiency. We are also looking forward to this year's event. Similar to last year, we will provide support to 10 trainees that will be attending the event. And hopefully the results of this program will be extending much beyond the project duration.
We're proud to announce the success of our skills and workforce development training activities, through which we have developed a set of exemplar notebooks that implement accepted artificial intelligence models for illustrative use cases using the Chorus dataset. These sets of open, exportable, and short tutorials can be utilized by researchers and trainees from various technical backgrounds. All tutorials combine didactic and experiential learning in Jupyter notebooks. And in our first year, we successfully developed 6 notebooks, and we aim to complete a total of 12. These tutorials serve as the foundational training material for other activities, such as artificial intelligence in clinical care workshops, future datathons, or tribal college undergraduate courses. In the long term, we envision this becoming an efficient way to indicate and recognize artificial intelligence literacy and competency, similar to many certificate programs in technical and professional fields.
The success of Chorus requires sustained engagement of scholars, healthcare practitioners, and broad stakeholder communities. Applying evidence-based team science interventions, we promote collaborative teamwork, support effective task work, and facilitate the participation of diverse groups of researchers, professionals, and health consumers in the AI and critical care scholarship. Since the inception of Chorus, we organized strategic team science workshops that were offered for the Chorus and broader Bridge to AI communities. Our work also received international recognition, and this year we're bringing our workshop to the annual conference on artificial intelligence in Vancouver, Canada, to foster broad engagement in AI team science and reflect on the inclusion of Indigenous peoples and citizen scientists in AI research.
We're developing this collaborative cloud together with a team of cloud engineers to ensure that the data is hosted in a trusted research environment, which is secure. This involves creating permissioning both to the hospitals, which will upload data, develop tools, and utilize the data, but also to the broader community who can access previously de-identified data in a safe location.
Chorus data meticulously capture the complete trajectory of more than 110,000 patients undergoing clinical care to recover from life-threatening events such as trauma, major surgeries, burns, and strokes. This data is multidimensional, spans multiple time scales, and is continuously influenced by treatments and complications. Each record reflects a unique human experience, therefore requiring a data sharing effort that transcends isolated files and database objects. Hence, we are developing software applications to ensure that the data is accessible in an intuitive way for comprehensive understanding of each patient's journey and appreciation of the nuances of clinical care before one starts to develop AI machine learning models. Using these applications on our Chorus Cloud platform facilitates deep engagement with data and fosters community-wide collaboration and knowledge sharing, thereby enhancing the collective understanding of this complex data and paving the way for innovative healthcare solutions. Cohort adjudication and data annotation, CADA, is an exemplary application that supports community-wide effort to label and adjudicate data, a key step in AI machine learning research and development cycle. CADA already supports data modalities such as physiological waveforms for labeling cardiac arrhythmia, as well as clinical notes for many natural language processing tasks. A new application, Model Meets Data, or M2D, which was recently conceived and is under active development, is to support publishing model cards and benchmarking AI machine learning models. A third application, Integrated Viewer, when fully developed, will provide key functionalities to support patient cohort discovery, flexible display of data that can be tailored to a specific clinical investigation, and interrogation of models to uncover biases. We deliver these applications with the vision that they can immediately serve the community and can be further modified, expanded by the community using standardized application program interfaces that will be released in public.
First, we decided to release Chorus API, not only for application development, also for research investigators and machine learning engineers could work with Chorus data. This is an integrated viewer apps repo. It's public repo, and you can go and see the usage features and tasks and everything. So integrated viewer is a web application designed to sit on top of Chorus source data and to support visualization, interrogation of Chorus dataset. Here are the features. I won't go into a lot of details, but let me give you where we are at development. Here you go. So of course we could be able to interrogate each tables, OMOP tables, but also we can interrogate and be able to save the interrogation. Sepsis. And these search results, these filters can be shared with other users, or saved, and you can come back to visit it again. And on an integrated viewer, we are designing this to be the widget style, and we want user to be able to put whatever data model they want to put, but also design their own dashboard. So depending on whether they're working on sepsis dashboard or ARDS dashboard, they can bring their own data, and they are able to make their own widgets as well, design that. And we will have marketplace of widgets that community would build, and we will enable that building experience. And that's where we are going with this application.
Hi, I'm Andrew Williams of Tufts. I'm going to give you a 100,000-foot view of the standardization work we've been doing in year one of the Chorus DGP, and then hand it off to my colleague Jared Hoteling, who's going to give you a little more detail. We're using the OMOP Common Data Model to harmonize information from all these sources because it's got a very rich, very detailed vocabulary that allows us to harmonize data across sites and to use a set of tools that are designed to work with data in this format. That includes the data quality dashboard, which runs thousands of different data quality checks and helps us to assure the overall quality and conformance of the data to the standards that algorithms expect.
And I'm going to talk briefly today about the work that we're doing to help sites transform their data into a common format and then submit that data to a central location for use in AI applications. So we're asking sites to actually execute a 7-step process where they're characterizing their source data in the 5 modes that Andrew described. They're then constructing mappings from those data into a common format, here the OMOP Common Data Model. They're actually then deploying those transformations and then kind of integrating those mappings into a pipeline to create this data set in OMOP format. They're then able to execute open source quality tools against that resulting data set to check to see if it conforms to convention and if it captures the necessary granularity from their source. They can then de-identify those data sets to remove any PHI or other potentially sensitive information, after which they can organize those data into a structure that we've defined and then share that kind of structured extract with the central team at Massachusetts General Hospital. And one thing that we've done to assist sites with this process is we've created a progress tracker. And by that, I mean a Google form. So we have actually distributed this particular Google form to the data managers per site that contains questions on status of various elements in that process I just showed. And that form then, when they submit, updates a public GitHub repository and changes the statuses of the associated elements in this particular GitHub project. So what I'm showing is the per site set of statuses across these different elements of interest, from submitting their data to completing the transformation, this extract, transform, load process, to then executing different data quality checks on those data.
Thank you so much for being interested to learn about all the people working so hard on this project. There's still so much to talk about and so many more people you can meet. If you're interested in our project or in Clinical Care AI. You can find us at our website, chorus4ai.org. That's the number 4. And you can stay up to date there on events that we're having, presentations, or training sessions, including AI boot camps or clinical care AI training sessions. Please join us if you'd like to reach out and learn more. Just contact us there. We're hoping to create an AI for clinical care infrastructure that will really benefit patients that arrive in the most vulnerable situation and are looking at us to really improve the care that we deliver. Thank you so much.